Okay, so I want to talk briefly about risk matrices and their use as a tool within risk management. The oil and gas industry is inherently associated with high risk. There can be huge impacts involved in terms of business, safety, the environment, when we get risk management decisions wrong. If we look at a simple risk management process, first we need to identify our risks, quantify our risks, qualify those risks, and ultimately make a decision. That decision may be to eliminate the risk, reduce the risk, or accept the risk. And if we reduce the risk or accept the risk, we then need to monitor that risk continuously to make sure our risk profile hasn't changed. So when we look at the different analysis techniques that we have to quantify and qualify risks, one of the most simple tools we have is the risk matrix, and that allows us to make the right management decisions. So we're all familiar with the basic concept of a risk matrix. Here we plot consequence of failure against a scale of likelihood of failure. That then gives us a risk score that can be graphically shown on the matrix, and often we colour code those risks to show our organisation's tolerance to different risk levels. In any risk assessment, we can then plot all our risks on the same matrix and we get a good indication of the distribution of risk across our assets. We're all familiar with risk matrices. They come in various different sizes, shapes, scales. We all use them every day. We probably have one up on the wall or on the desk in front of us. And probably because we use them so frequently and they are so embedded within our organisation's risk management procedures, we maybe don't take the time really to think about their limitations. So there's quite a lot of criticism for risk matrices out there. I put a few up on the screen behind me. I'm not going to talk about all of these today, but I would like to talk about a few. So the first limitation that I'd like to talk about is understanding scales and our ability to understand those scales. So within the context of integrity management, we use matrices frequently in methodologies such as risk-based inspection or anomaly management. And we often have a scale of consequence from minor to catastrophic. This is plotted in an ordinal scale from 1 to 4, and it usually comes with some semi-quantitative consequence description, so minor being an economic loss of less than 2.5 million, or catastrophic over 250 million. So to sort of understand this and put it in context, if we were to compare a minor consequence of failure, less than 2.5 million, to a catastrophic consequence of failure over 250 million, we need to be aware that a catastrophic loss isn't 4 times a minor loss, it's actually 100 times a minor loss. So when we look at a risk matrix, as we move along the risk matrix from left to right, the range within each cell gets higher. So for example, a risk score of 9 could be any economic loss value from 25 to 250 million. However, if we were to look at a risk score of 3, it could be anything from 0 to 2.5. So the boxes are not equal, and we can't really get away from this by putting in more boxes. The other criticism for scales within risk matrices is when we come to look at likelihood of failure. And the biggest criticism here is that we use so many words to describe a probability within the scale. So if we look at unlikely, and we notice that we use impossible and unlikely to describe an unlikely event. And if we look at an almost certain event, again, we use words like likely several times to describe that event. So the criticism here is that they're far too subjective and ambiguous for people to use consistently and correctly. The other limitation that's been identified with risk matrices is something called compression, and this is usually seen when we adopt a common risk matrix within our corporate framework to drive decision making through every level of our organisation, that when we come to adopt the same risk matrix in every methodology, that we run the risk of compressing the matrix. And to give a good example of that, if we were to look at anomaly management, so with anomalies, we're now not talking about uncertainty or risk. These are known defects, and they will fail at some point in the future. So knowing this, you've already taken out the unlikely or the possible descriptions from your matrix, and you've pushed all your anomalies over to the right-hand side. And when you compress the matrix in this way, you lose your ability to prioritise the risks. But this is something we know, and this is a quote from one of the ISO standards, and it says that a matrix should be designed to be appropriate for the circumstance, so it may be difficult to have a common system applying across a range of circumstances relevant to an organisation. One of the other limitations when it comes to risk matrices is something called layering. This is when we try to adopt a common framework, but in order to make it fit our methodologies, we add some layer to the likelihood descriptions. So in this example, if we look at risk-based inspection, so here we're trying to predict when pressure-containing equipment will fail in the future. And one way we can do that is by doing remaining life calculations. And so we can add another layer on the likelihood description to put some sort of time to failure. So for example, in this risk matrix, we could say that equipment unlikely to fail has a remaining life greater than the design life, or equipment that will almost certainly fail has a remaining life that is less than a third of the design life. So that allows us to spread our risk across the matrix, but we need to be aware that when we do this, that everyone outside our own department knows that that's what this means. So if we're using one common framework, and people outside the integrity department look and see a risk 12, we're not saying that that's an immediate danger of failing. What we're saying is that in our risk-based inspection methodology, it's priority for inspection because it's coming towards the end of its useful life. Another example would be anomalies. So one of the layers that we might put on anomaly assessment might be, again, some time to failure. So if we identify a defect and we assess that to be less than 1 year to failure, we could say it's almost certain. Or if we assess it to be more than 5 years to failure, we could say it's unlikely. But again, we need to be careful about this limitation. If we look at two risk scores of 8, both moderate level risk, and could be considered the same priority, what we need to be aware of here is do we liquidate the moderate almost certain risk that has less than a year to failure, or do you liquidate the possible but catastrophic anomaly that you may have 2 to 5 years to deal with? So we need to make sure that we're not skewing our own organisation's risk acceptance levels when we add layers to our matrix in our organisation's risk assessment methodologies. So the point to sort of take away from this is that matrices should not be taken too literally, since the scale of the axis is only indicative. So one of the other limitations when it comes to risk matrices is our own human cognitive bias. So cognitive bias affects our decision making. This idea that the way our brains think about events and remember events will be biased based on our own experiences. So for example, imagine if you have been organising a barbecue for this Saturday and you've been checking the weather all week, and you get to Friday night and the forecast tells you that there's only a 5% chance of rain, and then you get up on the Saturday morning and it's raining, and you think, typical, you know, the one day that I didn't want it to rain. But the point here is that your brain won't remember every time the forecaster told you that there's a 5% chance of rain and it did or did not rain. You will only remember the one time there was a 5% chance of rain and it rained because it ruined your barbecue. So the next time you go have a barbecue and there's a 5% chance of rain, your own bias will tell you that it's most likely going to rain. So how does that work when it comes to using risk matrices? Well, there's a lot of studies done in the 1970s about decision making and human judgment. And it kind of tells us that people think in one of three ways. When asked to score risk events on a matrix, people will either go worst case or assume that there's no controls in place. Some people will assume that there's some degree of control, whether they believe that control will be effective or not. And others will go absolute best case, there's full control, nothing could ever possibly go wrong. So we need to be aware of that when asking people within our organisation to use the same matrix. There was a more recent study done in 2013, and this gave people the same risk event and asked them to rank it on a 4x4 matrix. And what the study shows is that, yes, you've got your people who are very risk tolerant and scored in the low level risk region, and yes, you've got your people who are very risk averse and scored in the high risk region. However, the majority of people kind of went somewhere in the middle. And what they concluded from the study was that when people didn't have enough information to be confident in their ability to score a certain risk event, they almost always went for medium consequence, medium likelihood. They played safe, if you like, and they all score in the middle, and the risk scores bunch in your matrix. So I thought this was interesting, and I thought I'd try it for myself, so I emailed out a number of my colleagues, and I gave them a risk event, and I asked them to score it on a 4x4 matrix. And the event that I gave them was the release of hydrocarbon gas on offshore platform due to degradation of pipework. And a lot of them came back and asked for more information, but I deliberately said, I want you to score it based on that sentence only. And here were the results. So the majority of people sort of scored in the high risk region, and a few people scored in that sort of moderate level of risk region. And what I thought was interesting about this was that everyone who's in that top right-hand box were people with less than 5 years experience in the industry, and everyone who's in that yellow middle region, moderate risk, were people with over 10 years experience in the industry. I then went back and gave them more information, and this time I gave them additional detail on the type of process fluids, the remaining life, the specific failure mode, the location of the pipework. So more information that they could use to more confidently make a decision. And what happened was that regardless of people's experience, everyone then ranked in the same risk level, this moderate region of risk. So we're never going to get away from bias in the use of risk matrices. However, there are probably a few things that we can do to sort of reduce the subjectivity. So if we give people better understanding on sort of our own cognitive biases and how we use the matrices, if we can give people access to the correct quality of data, if we can make sure that everyone is ranking the same credible risk event, and any assumptions that we made when doing the assessment are made clear, then we should get more consistency when using the risk matrix. And that sort of brings us on to the next point, which is information, data quality and availability. And a lot of the research suggests that if you increase the quality of your data, if you arm people with the right information, then you can actually reduce the subjectivity when carrying out risk assessments. So those are some of the limitations, but what's right about the matrix? They're simple to use and understand, they're easy to construct, they're a very good screening tool, they can allow you to prioritise larger volumes of risk, they give a very good visual representation of risk, they promote really good discussion around risk management, they are a common language if we are all aware of their limitations, and they're really invaluable for aiding informed decision making. They're also a really good way of graphically presenting the results of any risk assessment on many different items of equipment. So to give an example of that, if you were to plot anomaly data on a risk matrix, you can then extrapolate that data and show it in different graphical forms. So this example shows anomaly counts by system, so you can quite easily see which systems carry the highest amount of risk, or alternatively, sort of cumulative risk score by system, so you immediately see that system 4 is carrying the highest level of risk. So the point that I sort of want people to take away is that the risk matrix is a tool which can be used to support risk-informed decisions, but ultimately they're not a tool for making decisions. If we go back to a risk management process, yes, matrices do have their limitations, and they may only be a rough approximation tool for risk analysis, but they are invaluable for distinguishing between the most urgent and the least urgent risks in the majority of cases. So if we can use them effectively as a prioritisation tool, then ultimately we can make the right decisions on how to best manage risk.